Okay, so this is exercise 5.4, Q1, number 10. Some people had some problems with this one, so I wanted to do it with a video instead of typing it all out. So I basically put the problem here as it exists in the book, except I'm using keyboard symbols. So remember, this is biconditional, this is conditional, the ampersand is for conjunction. And I put, the brackets in as best I could. So what's going on here is you got two premises and your conclusion is a conditional, right? So that's why the first step here is to start with the conditional introduction. So when you do conditional introduction, you assume your antecedent of the condition you're trying to prove, and then you want the consequent. So that's the first thing you have to fill in here is the S biconditional not T. Okay, so again, assume P, assume the antecedent, want the consequent. Now this thing after want it's not a premise you have to work with. It's just to remind yourself what you're trying to get. Once you get this, the subderivation ends. So you can see down here when we get S biconditional not T, that's the last line of this subderivation that starts with P, all right? And then after that, we move back to the original indent line. So this is just telling us what we want. It's not a premise that we have to work with. All right. So how do we get a biconditional? Well, the biconditional introduction rule, right? So whenever you're trying to get something, you should think introduction rule. So if I'm trying to get a conjunction, I should think conjunction introduction. If I'm trying to get a conditional, conditional introduction. If I'm trying to get a biconditional, biconditional introduction. So the biconditional introduction, though, requires you to get two conditionals, right? Because a biconditional is equivalent to the conjunction of two conditionals. So first condition we have to get is S conditional not T, right? This would be the antecedent, this is consequent. So that's why what we fill in here is our not T. So we need to get S want not T, or we need to get the conditional if S then not T as the first part of the biconditional introduction. And you can see we can get not T in one step. Well, how do we do that? Well, again, look at our premises up here. We've got not T as the consequent of a conditional, and we do have S, which is the antecedent down here. So we can derive not T using the conditional elimination rule, lines 1 and 4. Right? So line 1 is a conditional. Line 4 is the antecedent of that conditional. So as output, we get the consequent. So we started with S want not T. We got not T right away. So we can now put that back here and write S conditional not T. And we get that by conditional introduction, 4 and 5. So this subderivation gave us the conditional, if S then not T. Now notice this, we stay on this indent line, right? Because this was this was the assumption S, we wanted not T. So we did move back one indent from our assumption, right? But we didn't move all the way back because our assumption was indented twice, right? So now we need to get the other half of the biconditional, which is just flipped around. Not T as the antecedent, S as the consequent. So that's why we have not T want S here. Again, we can get S in one step using the premises we have. So in this case, since we have not T, we can use the disjunction elimination rule, 2, 7. So line 2 is a disjunction. Line 7 is the negation of one of the disjuncts. So as output, we get the other disjunct. So now again, we move back one indent line. Whoops. And that gives us not T then S. And the justification is already filled in. Conditional introduction of 7 and 8. Okay. So we did those two subderivations to get these two conditionals that will go together to make the biconditional. Sorry, this biconditional. Right? So a biconditional is equivalent to two conditionals, one with the antecedent consequent, right? And then the other one with the order flipped around, consequent antecedent. So we get the biconditional then, that's the material we needed for the biconditional introduction rule, lines 6 and 9. And again, that biconditional is what we wanted here at the very beginning. So now we go back to the original indent line because we assumed P, we wanted this, so we got it. So we go back. And what justifies that is the conditional introduction rule, lines 3 through 10. All right. So again, the numbers you get here, line 3, or the first number should always be the assumption that you started with. So we started on line 3 with P. We wanted this. The second number should always be where you got this, where you got what you wanted. So we wanted S biconditional, not T. We got that on line 10. So 10 is our second number. All right. So the derivation then, overall, we're trying to derive this conditional. That's the first assumption. But then we need to derive the biconditional since that's what we want. So we do 2 conditional introductions to get the biconditional, and that finishes our derivation.